in ecosystems. Today's date is December 2nd, 2020. And it is the 6th lesson of our 9th unit. Today is the last day of our 9th unit, which means that we have a test tomorrow. Okay, so please do make sure that you are looking over your notes. This was a relatively easy unit because it was information that you all have learned in the past in middle school, in elementary school, and also last year in earth and environmental science. But you should take it as an opportunity to review some of your older material, which is a good thing because we are almost exactly 2 weeks out from our EOC exam. The EOC exam will be given 2 weeks from tomorrow. So if you can review older information in preparation for tomorrow's test, you're also doing yourself a service by preparing for the EOC, which is about 2 weeks away. All right, so take an opportunity to look over your notes tonight, look over some of your missing assignments, even if they go back as far as Unit 6, and just try to take care of them so that you feel better about the exam tomorrow. The objective for today's lesson is to evaluate the flow of energy in ecosystems by analyzing food chains and webs. And the essential question that we seek to answer, how is energy transferred between organisms within an ecosystem? So please do make sure that you have that introductory information written down, and we will go ahead and get started. It should be a quick lesson. All right. So what we're seeing here is not quite an energy pyramid, but it does show kind of the cyclical nature in which energy is transferred from one organism to the next, how energy is coming from the surrounding environment, how organisms take up energy via their nutritional habits. So we can see that taking place in this cycle over here. In short, energy flows from radiant energy, which is coming from the sun, into chemical energy, otherwise known as glucose. And that glucose is ultimately transformed into heat energy. Just like when you and I eat our lunch and then we walk around for a little bit and then we sit down and we type on our computer and we're moving our muscles the entire time, some of that is leaving our body. Some of that energy that we're using to move is leaving our body as heat. All right, so that's what we can see on this slide. Now, there's one important structure that I would argue probably is the most important structure that is missing from this cycle. Does anybody think they know what that is? What's not here?
Can you say the question again?
Yes. So something I think probably the most important structure that's a part of this energy diagram is not actually here. We have the word in our sentence over here, but we don't see it represented in picture format over here. What is that word that's missing?
Sun.
The sun. Excellent. Thank you, Jada. The sun is really the source of all of this energy. It's the source of all of this heat. And so we really should have that represented somewhere in this diagram. For whatever reason, whoever made this diagram chose not to put the sun there. But the sun is really, really very important because it is the ultimate source of all of this energy, all of this heat. When we think about energy being transferred from one organism to the next, it's often useful for us to take a look at food chains or food webs so we can see exactly how organisms are consuming each other, how they are being consumed, and then from there we can really get a picture of where energy is moving throughout an ecosystem. Food chains and food webs show the flow of energy and nutrients within an ecosystem. A trophic level, is each step in the food chain or in the food web. So as we move up the food chain, we're moving through different trophic levels. So someone help me understand what I'm seeing here. If I start down here in the berries, what happens to these berries? The image is telling me information. Can you help me understand better what's happening to these berries?
They give them nutrients and energy.
Okay, thank you, Jaden. Who exactly is getting nutrients and energy from the berries? What organisms?
Butterflies.
Butterflies? Anybody else?
Grasshopper.
Grasshoppers, green flies, and then there's one more organism as well.
Rabbit or mouse, one or the other.
We don't see any direct link from the rabbit or from the mouse to the berry.
Oh, you're talking about the berry.
Yep, the berries. If we were talking about the plantains, then yes, we can see that the
Oh, the
mouse.
green fly.
What'd you say?
The green fly.
I think someone said green fly as well. The only one we're missing is the titmouse. The titmouse. Right, so, and then what happens? Let's say we look at the grasshopper. What happens with the grasshopper? The grasshopper is getting energy and nutrients from the berries and from the plantains. But what then happens to the grasshopper?
It gets eaten by the frog.
The frog eats it. Thank you, Joseph. What else does the frog eat?
The frog eats the dragonfly, and the snake eats the frog.
Good. So we can follow these arrows to determine which organisms are eating other organisms. So the frog is eating the grasshopper. We can also see that the frog will eat butterflies as well as dragonflies, and that's what Jaden told us. And then snakes, if they can catch up to a frog, will happily eat the frog as well. Does anybody eat the snake?
Buzzard, but the buzzard is target though, because I think
The titmouse.
no, it's not. Oh, yes, it is. I think
The titmouse.
Okay, let's be careful. Is the titmouse eating the snake, or is the snake eating?
The snake eats the titmouse.
The snake is eating the titmouse. So
yeah.
we got to be careful about the direction of these arrows.
But
you're right. I think that was Jaden who said it. The buzzard is eating the snake. Who would be considered the top predators in this food chain or this food web?
Snake, buzzard, fox.
Fox.
Good. All right. Now, I heard you say buzzard and fox. Those are both correct. I would argue that the snake might be a level under them because the buzzard eats the snake. So something is eating the snake, but we don't see any other organisms eating the fox or eating the buzzard. So they're at the very top of the chain. All right, good job. So that's how you read these food webs. Now, there are some specific words that we can use to describe the trophic level of an organism. A producer is any organism that uses energy from the sun. It also uses water and carbon dioxide to do photosynthesis, to make its own food. Of course, the grass that you might have outside of your house or the trees that you might see outside of your apartment, these are not able to just kind of pick up and walk around and find flies to eat or find mice to eat. Of course, they don't eat other organisms. They need to produce their own food. And the process that they use to do that is called photosynthesis. We've talked about that before. So that's where the word producer comes from. They are producing their own food. Consumers, of course, don't produce their own food. They have to consume something else. A primary consumer consumes producers. They are the first level above producers. Okay, so this is why we use the word primary, because they are first. Primary consumers consume producers. Secondary consumers are a level above that. They eat the primary consumers. Tertiary consumers are a level above that. They eat the secondary consumers. And then you might see another tertiary consumer, or perhaps what we might call a quaternary consumer, or a top predator, an apex predator. And that apex predator is going to eat the tertiary consumer. The cool thing about it is we can really establish a cycle here, because when these things die, assuming that they are not eaten by something else, but they die and their body is just left out to rot, they will eventually be decomposed. And as the nutrients and the biological compounds that were once a part of their body get returned to the soil, they also help with the growth of plants and fungi and other organisms that benefit from those nutrients. And then, of course, those plants and fungi can be eaten yet again, and the process starts all over again. All right, so it's a cycle. It's where we really come up with this idea that matter can neither be created nor destroyed. Energy can be neither created nor destroyed. These things are being recycled. Now, if we were to take this food web and put it into a pyramid, what should go at the bottom of the pyramid? What should go at the bottom of this pyramid? Thank you, Nick. The producers. We should always put the producers at the bottom. And then right above that, we would have your primary consumer, for the crickets in our example. After a primary consumer, of course, comes a secondary consumer, which were the mice in our example. Then we have a tertiary consumer, which were the snakes. And lastly, we had our top predator, which were the hawks. So this is what these pyramids look like. Now, the interesting thing about these pyramids is that they are a pyramid. They're getting smaller and smaller for a reason. The reason for that is really twofold. Number one, you've got way more blades of grass than you do crickets. You've got way more crickets than you do mice. You've got way more mice than you do snakes. And you've got way more snakes than you do hawks. So as you move up the pyramid, you're getting fewer and fewer organisms. There might only be a couple dozen hawks living in the ecosystem, and maybe there are a couple hundred snakes, and maybe a couple thousand mice, and maybe a couple 100,000 crickets, and there are millions of blades of grass. All right, so the organisms at the top, there aren't many of them. The organisms at the bottom, there are a lot of them. The other reason is because of energy flow. So the left side of the screen reads, energy pyramids represent energy flow through trophic levels. The pyramid starts with 100% energy, but only 10% of the energy is gained as it goes up the food chain. So what this means is that as you move up each level of the energy pyramid, 90% of the energy is unavailable. Okay, so if we go back to our previous example, we had producers on the bottom. That's what Nick told us to do, and he was correct. We put grass on the bottom. The grass is going to absorb 100% of the energy from the sun. But then when the crickets come along, only 10% of that energy is available to them. The reason is that the grass has needed to use the energy. It needed to use the energy to establish deeper roots, to grow. The blades of grass obviously get longer, and that takes energy. It needs to use that energy to reproduce. All right. So as we move up in the energy pyramid, organisms are using energy so that there's not as much available to them on each level. Then we had mice come along and eat the crickets. Well, the crickets have been jumping around, they've been reproducing, they've been pumping blood throughout their bodies, they've been excreting waste from their bodies, and all of those processes require energy. So that means that they've used the majority of the energy that they've taken from the grass. So even a smaller percentage, only about 1%, is available to the mice when they eat the crickets. And then we move up again. The snakes eat the mice. The mice, of course, have been running around. They've been reproducing. They've been moving their noses and whiskers, trying to sense their environment. All of that takes energy. And of course, along the way, all of these organisms are also giving off energy as heat. Maybe some of you have seen heat maps before, where you can kind of scan the environment. You can look through these special goggles and scan the environment, and you can see that living things are giving off heat. And so they appear orange instead of being blue. They're giving off heat. All right, so as we move up the pyramid, there's less and less energy available because most of it has been used up, or it has been kind of lost, quote unquote, lost as heat. Again, if you've joined the video chat late, please do send a message to the chat so that I can make sure that I record your attendance appropriately. Thank you. I see we've had several new people join us. Okay. So if the grass starts off with 100% of the energy coming from the sun, how much is going to be available to the crickets?
Can you leave it like that real quick? Hold on.
Yeah.
90.
Okay, so you just subtracted 10%. Well, what we're saying is that only 10% is available. So Alyssa is correct. 90% of it gets lost, Kyrie. 90% of it is lost. So we just need to divide by 10 every time. So then how much would be available to the mouse?
0.1%.
Not 0.1, but just 1%. We're just dividing by 10. And then how much would be available to the snake?
Then that's 0.1.
That's 0.1. And then the hawk, of course, gets 0.01. So again, as we move up, all we're doing is dividing by 10, dividing by 10. Another way to think about this, as we move up, we're moving the decimal place over to the left 1. So I start with my decimal place right here with 100. Oops. I move over to the left 1 and I end up with 10. I start off with my decimal place right here. I move it over to the left 1 and I end up with 1%, and so on and so forth. I'll go back for a second. All right. So I want you guys to do these practice problems in your notebook. We've got an example pyramid over here on the right side of the screen that you might want to copy down in your notebook. But I'm going to set a 5-minute timer, and you all will answer these questions, and then we'll talk about them. All right, so hopefully you took a look at these questions and you wrote them down in your notebook and we're ready to go over them. The first question prompt asks us to create an energy pyramid with the following food chain. So we've got our pyramid on the right side of the screen. Oops, I just gave it up. But which should go on the bottom of the pyramid?
Leaves.
Leaves, and then what comes after that?
Insects.
Keep going.
Bird, red fox, and bear.
Excellent. All right. So where in this energy pyramid is the most energy and where is the least energy?
The most energy is the leaves, the least is the bear.
Excellent. So the most energy is at the bottom where the leaves are getting their energy directly from the sun. And then the bear at the top of the pyramid has the least. And this explains why organisms at the top of the pyramid and as you move up the pyramid have to eat so much more food, right? A bear has to basically constantly be eating in order to get the amount of energy it needs to survive. And it has to eat larger organisms. What happens to energy as it moves through the food chain or through the food web? What's happening to the energy?
It's getting passed down or something like that.
Okay, so some of the energy is really lost through heat. It's converted to heat energy. And then also the organisms have to use the energy to live their daily lives. They have to use energy to reproduce, to drink water, to go in search of food, to play, whatever organisms are doing. They need to use energy to do all of those things. So of course, some of that energy is not going to be available to the next level, the next organism. The next prompt tells us to assume there are 10,000 kilocalories of energy in the leaves. Estimate the amount of energy in each of the levels of the energy pyramid and label it on the pyramid. All right, so we start off with 10,000 kcals in the leaves. How many kcals should the insects have?
Shouldn't it go down, right?
It should
1,000.
go down.
Like take a number away. I think it was something like that. Like you had to take a
1,000.
number away or whatever.
Good, Joseph. We should have 1,000 here. We're dividing by 10 every time. So what comes next?
100.
100. Then what? 10.
1.
And only 1. Good. So we can see how the amount of energy is drastically decreased as we move up the pyramid. And then our last question, what is the ultimate source of energy for this food web?
I would say the sun, but it's leaves.
But the leaves get their energy from the sun. So the ultimate source of energy is indeed the sun. So I'm going to leave this up. Make sure that you have written this down somewhere in your notes. This was good practice. Excellent job, Jaden and Joseph. I appreciate the help. All right. So we're looking here at this food web. I'm not going to start the timer. I just want to go through this together. What are the producers in this food web?
Carrots, grass.
Carrots, grass, and grains. Excellent. What are the primary consumers in this food web, and what do they eat?
Rabbits, mice,
Rabbit, mouse,
grasshoppers, meat, carrots, grass, and grains.
Good. The primary consumers eat the producers. And in this case, the primary consumers are the rabbits, the mice, and the grasshoppers. What are the secondary consumers in this food web?
Fox, owls, birds.
Okay, good. So the secondary consumers are, of course, eating the primary consumers. So these would be the foxes, the owls, and the birds. What is the highest level consumer in this food web?
The fox.
The fox. Now we can even call the fox a tertiary consumer because if we look, The fox eats the bird, which is also a tertiary consumer, because the bird eats the grasshopper, which eats the grass. So there are 1, 2, 3 levels to get to the fox. So we can consider it a tertiary consumer. Which trophic level contains the greatest amount of energy? Which level has the greatest amount of energy?
Oh, the primary consumption. Well, not primary consumption, but the grass, grains, and carrots.
Thank you, Kyrie. Yes, the grasses, the grains, and the carrots, those are the producers. They do have the most energy. And again, where do the producers get their energy? Where do the producers get their energy?
The sun.
They get it from the sun. Thank you, Joseph. All right, now I don't need you all to write this down, but I want you to talk me through it. So if we're looking at this food web here, let's say that we chose an organism to take out of the ecosystem. We're just going to remove them from the ecosystem. I want you to talk to me about what the impact on the rest of the ecosystem would be. So someone take themselves off of mute, choose an organism to remove from the ecosystem, and talk to me about what the impact would be.
The rabbit.
Okay, so Joseph, you want to remove the rabbit. What happens to the rest of the ecosystem if we got rid of all of the rabbits?
I feel like it'll go down because they have to either try to find something else to eat, which they haven't adapted to yet, or I don't know. They just have to
Okay,
find
good.
a new food source.
I know.
Good. So, and which organisms are you talking about specifically that need to find a new food source?
The jackal, and the wildcat.
Good, the jackal and the wildcat. And if we take out all the rabbits, so we're going to see the jackal and the wildcat, like you said, they're going to have to look for another source of food.
Well,
What else?
the jackal's food source is the goat, but that mean the goat's gonna be decreasing because
Okay, eat the mouse.
Excellent, Kyrie. And I can't really hear you, Joseph, but I'm just going to repeat really quickly what Kyrie said. The rabbits are preyed upon by the jackal. The jackal eat the rabbit. If the rabbits are taken out, that means that the jackals are going to have to turn to another food source, like the goats, and eat those more often. So we're going to see the population of goats actually decrease as well, because the jackals are going to start eating them more often. What else is affected here? Because it's not just everything that's above in the food chain. There are also things that are below the rabbit in the food chain that will be affected as well.
The plants will increase.
The amount of plants is going to increase. Good. So the green
mice would probably increase.
Good, and the mice might increase as well. So we might see more plants being produced as there aren't any rabbits to eat the plants. Okay, so the population of the plants will increase.
Mr.
Excellent. Yeah.
The mouse population, they're gonna be ate by the wildcats still.
They would be, yeah.
Yeah.
Yeah. So we can see how this has ripple effects throughout the entire ecosystem. And this is actually something that happens in real life. In Yellowstone, in Montana, for a long time, the gray wolf population has been decreasing. And because of that, the amount of deer in the area, which would typically be preyed upon by the wolves, the deer population is increasing dramatically. And this means that when you have more deer, they're eating more and more plants. They're eating more shrubs and bushes and grass. When you take out those plants, the soil is looser. And so the area is more prone to mudslides, and it creates a lot of damage in the area, in the surrounding area. So, and we can literally know that that's because the wolf population has decreased as they've been hunted. They've been overhunted. So it's a big problem. So when you remove one organism from the population or from the ecosystem, it's going to have a larger effect on the entire ecosystem. Good job with that. All right, so there is an extra credit activity available to you all on Canvas in this Unit 9 module all the way at the bottom. I don't want you to do that if you know you have missing assignments, as many of you do, as most of you do. Do the missing assignments first, and then you can think about coming back to do a food web. Today, we do have an exit ticket. We also have an asynchronous assignment. So go ahead and knock both of those out. It shouldn't take you too long to do them. The Amoeba Sisters asynchronous assignment is going to require you to watch a few videos as you answer the questions. So please make sure that you're doing that. And then once you're done, we have about 30 minutes left in class at this point. You should go back and continue making progress. I have seen many of you making progress on your missing assignments, but there's still a lot more to be done. Don't be discouraged, guys. I know we're 2 weeks away from the EOC. We're about 2.5 weeks away from grades being stored. So there's still time for you to get this stuff done. And it's also going to be helpful to you to review some of that work in preparation for your EOC exam. So don't be discouraged, just keep making progress day by day. I'm seeing some of you work at it every day. I'm seeing some of you improve. That's a good thing. I don't want you to be discouraged. Keep asking for help when you need it and just keep moving forward. Don't look back. Don't say, I wish I would have done this. I could have done this differently. I should have started earlier. All you can control now is what you do going forward. All right, so knock out these two things. They shouldn't take long. You should be left with some time to go back and do some more missing assignments. I'll be here on mute if you need help.
Mr. Rudd,
Yes.
I got a question.
Yes.
Is Kool-Aid and Capri Sun the same thing?
Is what?
Kool-Aid and Capri Sun the same thing?
I don't think so. Why?
It's the same thing.
Is it really?
Yes. It's practically the same thing. It's practically the same thing. Open bags.
I have to look that up. I feel like they taste different.
Oh, but barely. All right. Appreciate it, Mr. Rudd.
Mr. Rudd,
Yes.
is the Bieber Sisters energy review, is that like a grade, like a formal
What's
grade?
that?
Is it a grade, like a formal grade or something?
The Amoeba Sisters?
Yeah.
Yes, it's an informal grade. Yeah.
All right.
All right, folks, it is now 1:20, so it's time for you all to get ready for your fourth block. I'm going to stop recording, stop sharing my screen, and let you all get